All right, good afternoon to my Calc 2 students. So we're looking at problem number 3. So we have, suppose the labor cost in dollars for manufacturing a camera can be approximated by this function. 3 halves x squared plus y squared minus 2x minus 2y minus 2xy plus 72. Okay, that's my labor cost. X is the number of hours of skilled labor. Y is the number of hours of semi-skilled labor. Determine values of X and Y that minimize the labor costs. And what is the minimum labor cost? Okay, so let's go ahead and have a look at this and see what this is going to be. So we have our labor, X, Y, okay, and skilled and semi-skilled. X is skilled, I guess. Y is semi-skilled. Okay. So we have that. And this is equal to 3 halves x squared plus y squared minus 2x minus 4y, okay, minus 2xy plus 72. Delightful. All right. And then we have to figure out what the optimization is for this. So what we're going to do is we're going to take our partial derivative with respect to x. Let's go ahead and have a look at what that's going to be. This 2 comes down in front, so we have a 3x. Y squared is held constant, so we have minus 2. Y is again held constant. We have minus 2y here, right? I'm sorry, minus 4y. There we go. Let's get rid of that. Oh, that's going to be minus 2. What am I doing? There it is. Yes, minus 2y. There we go. I'm looking at the wrong one. The 72 is the derivative. It's a constant, so that's going to be. We're going to set this equal to 0. Okay. The other thing we have to do is dl by dy. Okay. And again, we're just going to swap the position. So now x is held constant, so we're going to have a 2y. X is held constant, so minus 4 minus 2x, and we're going to set this equal to 0. Okay, so what we have here is we have two equations. We have a 3x minus a 2y is equal to 2. All I do is move the 2 over to the other side. On the other equation, I've got a negative 2x, okay, plus 2y equals 4. Okay, I just swap the order, I just put them so that my x is lined up and my y is lined up. We have two equations, two unknowns here. How do we solve this? Right? And we have to say, okay, we could do elimination, we could do substitution, we could do a lot of different things. But right now, since I've got a negative 2y in the top and a positive 2y in the bottom, all I'm going to do is add these two equations together. So 3x minus 2x is just 1x. The y's disappear, and x is equal to 6. Delightful. Pick any of the equations you have, okay? Pick either one, pick equation 2, either of the equations, and go ahead and plug in x is equal to 6 and solve for y. So we're going to say 3 times 6 minus 2y is equal to 2. Okay, I just plugged in x equals 6 into my first one here. So we have 18 minus 2y is equal to 2. We're solving for y here, so subtract 18 from both sides, subtract 18. We have minus 2y. 2 minus 18 is going to be negative 16. Okay, dividing both sides by the negative 2, we're going to get y is equal to, I believe, 8. Okay, so right now we have a x is equal to 6, y is equal to 8 kind of a solution. Okay, and so we're going to be able to say we have 6 hours of skilled labor, 8 hours of unskilled labor. Okay, and now we have to say something about like, hey, what was the actual problem? It was something about finding a minimum, wasn't it? So let's go ahead and look back up here and say, okay, we wanted to minimize the labor cost, so we can hope that it's a minimum. Let's go ahead. We have to do more. We have to say, okay, what is the second derivative with respect to x? Okay, so I'm going to go back up to my first derivative and say, okay, take the second derivative with respect to x here. It's looking like that value is going to be 3. Okay, so this is equal to 3. And I'm going to need d squared L dy squared. Okay, So I'm going to go up here to my dl by dy, and I'm going to say, okay, we need to take another derivative with respect to y of this guy right up here. And that is going to be 2. Okay, the last thing I need to do, because I need to get a d squared L, and we have to take the derivative of x and y. So we're going to look at, okay, what is my derivative with respect to x? So we have that. Now we're going to take the same derivative with respect to y. And look at that, I get -2. Okay, we're going to double check to make sure it actually is the same thing on both of them. So dl by dy, we're going to go ahead and take this derivative with respect to x. Oh, look at that, it's -2. You don't have to do this. I like to do this because this is not always true. So if you have f of xy, right, and you take the derivative of dx by dy, that's what that means. So just do it that way. This is not always the same as dy dx. It is for every problem in your book. It is for every problem that you will ever encounter in physical chemistry. It is for almost every time, but it is actually not a rule that these are going to be the same. Okay, what has to happen, it has to be continuous both in the x direction and the y direction. So it has to be continuous here and continuous there in order for you to have this the cross derivatives be equal to each other. Okay, that is not a theorem. That's not a rule that says they always have to be equal, because they don't. There are functions that don't exist in your book where they aren't going to be the same. Okay, one may not exist, the other one might exist. So realize that in every realistic situation you're going to be in, you can swap the order and it's not going to matter. But as a check, I like to make sure that it actually happens. Okay, so we have to go ahead and calculate out our D. Okay, just remember, like if you're ever on a true false quiz, I won't ask you, but if you ever had a true false question, like is, you know, um, f squared dx dy equal to f squared xy over dy dx. If this was a true false question, the answer would be false. Okay, it's not true that these are always the same. It looks like they are because every problem you're ever given, they are, and every problem you will be given that they are, but it is not a rule that that happens all the time. Okay, so we were all well on our way to figuring out what the minimum value is going to be. So we're going to say fxx times fyy minus fxy squared. And this is an AB, okay? So we actually have to evaluate this at AB if they aren't constant. Luckily for us, d squared L by dx squared is 3. Okay, so we're going to go back up here to say 3 times what is my y is 2 minus, and then we're going to go in and type in -2 squared. Okay, which is just, okay, 3 times 2 is 6, minus 2 squared is 4. So we end up with 6 minus 4, which is 2. Okay, so D is greater than 0. Okay, we're going to go back to our test here and look at the last page on your test. Okay, because you will have this equation sitting here on your test. Okay, so we have D squared, D is greater than 0. So do I have a relative maximum or a relative minimum? Is my fxx bigger than or smaller than 0? Okay, and right here it says, okay, dxx, there we go, is bigger than 0. Let's just double check what we have here. dxx is greater than 0. Hey, look at this. On this chart, it's a relative minimum. Okay, so this is a relative min. It's kind of cheating that they told us to minimize this whole thing, and that's what we were going to do. But it's nice to know that this is actually the case, that it's a relative min. And again, that you will have access to that chart on the exam. I'm not pulling that away from you. You have this. Okay, so we know it's a relative min, and then we want to know what the heck is the actual minimum value. Okay, so we go all the way back up to the value here. So I'm just going to rewrite the function. We're going to say L, and then what were our values? 6 and 8. So we'll go ahead and say 6, and 8, okay, was equal to, okay, and then we have 3/2, and then the 6 is the x value, so we have 3/2 times 6 squared plus 8 squared, because that's the y value, minus twice 6, minus 4 times our 8, okay, minus 2, and then we have x and y, 6 times 8 here, okay, and then finally we have a plus 72. So I'm just going back to the original function and typing in the values. I know you can do this, but we actually have to go through and deal with the fact that we have to do it. Okay, just get a calculator out and go to town with what you're trying to do here. That's exactly what I did. So I think after I ran this thing whole through my calculator, I actually ended up with a value of 34. Okay, so that's a nice problem. We have that. There's a reason why the 1, 2, 3, and then we reset back up to 1, 2, and 3. 1, 2, and 3 were problems I pulled off of a previous test. We went off into other things that we don't cover in the class anymore, like Lagrange multipliers. It's kind of cool, but they told us like, hey, we're taking this out of the class. Don't make the students responsible for this anymore. I'm like, okay, I got my orders from above, so we will not make the students responsible for that. So here we go with that was the last little part of the first when I wrote this test years and years and years ago. These were the first 3 problems. So you guys have similar problems, but since things have changed, we go ahead and change. So that's why the 1, 2, 3 is there, and we start over at 1. This was just previous, taken off of a previous test, and I just thought, well, I'll leave that so you guys have like a trail of breadcrumbs to know like what have I asked before, and what can you expect out of me if I'm doing stuff. So that's why they're there. It's not 1, 2, 3. Your practice test, your actual test is only going to have 8 problems on it, and we'll go with that. It's going to be. So I'm going to say thank you very much for watching the video, and thank you, and good luck with everybody for the exam. Okay, thanks.